Hello everyone. Today we will discuss on stack. Stack is a abstraction of data type with linear data structure in which time may be added or removed at only at the end. By this structure we can see that on the top of the stack we have the 50. Here we applied the function which is known as LIFO. LIFO means last in first out. That means in this section we have put the values 10, 20, 30, 40 and lastly we have put it the 50. If we want to pop those values, the 50 will pop first, which is the last in first out. The 50 ins in this section last and goes out first. That is why it is known as LIFO. This section is very important for your examination, that is stack works on LIFO abstractions. Those are the push pop terms that I have already discussed. In this push section is to insert the data and pop is to delete or remove the data from the stack. The basic operations of stack is to create, push, pop and empty stack. Create the stack, push the data, pop the data, and after popping all the elements the stack will be empty. Creating the stack. In this section of coding we can see how the stack is creating. We have a data section and here we have the max value. Integer, the index the name is variable is known as top and this is declared as a stack. Here type defined is structure stack. That's how we create the stack section. Pushing the data is to put the data. That means we have A, B, C data here and we need to push the data D on the top. That is the pushing section. In popping section, first of all in here we need to pop the value 15. We can't remove another sections without removing the value 15 because it is in the top, because it works on LIFO section which is last in first out. 15 ins last here and will be out first from here. So 15, 12, 10 and lastly we pop the value 5. Then it will become the empty stack. Array representation on stack. That is how we represent an array in the stack format. Explanation of one-dimensional array. We can draw this diagram here. Here, this one are the index numbers which are from 0, 1, 2, etc. And here is the values. Here the top value is 3 now. Operations. Top equals to -1. That means the stack is empty. Top equals to top plus 1. That means the value is to be incremented by 1. And top -1 means the value need to be decremented by integer 1. This table is important for your examination. Have a snap of this one. Push operation. By this code of function you can easily push the data in the stack. In this push section we have stack and here pointer is s and the value of integer is num. Here we have top equals s top plus 1. That means you are inserting the value and incrementing the index number by 1. Now, what is stack overflow? Stack overflow means you have the index value highest which is 5 but you are putting the value number 6. That is the reason of overflow. The number of maximum elements is overflowed when it is known as stack overflow. Here are some pop operations. One is argument and another one is by the return type. Here are some pop operations. In the pop operations, we need to decrease the top value by decreasing the indexing value, and we will pop the data. That is how the code works in pop function. How to check the stack is full or not. If the top equals to max minus 1, max means the maximum value of index, then the stack is known as full and it will return 1, otherwise it will return 0. That is how we can check the stack is full or not. This one is also very important for your examinations. Have a snap of this code. Here are some applications of stack which is given here. They can be expression evaluation, backtracking section. Backtracking means if you are going from A here, from A you are going to B and then you are going to C, but you want to go back to the B section again. So from C you will go back to the B section, that is known as backtracking. And memory management in runtime environment is also for is a application of stack. Infix, prefix and postfix. In this operation you can see that here we have A plus B. If we put the plus section before A and B, which is plus AB, which will it will known as prefix. That means the value will be predefined. The operator is predefined here, plus then A then B, which is prefix. Then infix is given here, which is A plus B. Plus is in A and B, so that is known as infix. Now postfix means right after. That means A then B then AB plus. This was the postfix notation. In this example, we can easily see what is infix, prefix and postfix. This is the prefix notation. Her plus is prefixed before A and B. In postfix, it will be after A and B, which is postfix, and infix in the inside section. The difference between those three are very important for examination. Here is an algorithm which we can go through by which is known as the postfix evolution. You can have a snap of this one. Infix transfer to postfix means we need the value infix is given here. We need to transfer the infix value into the postfix section. How we will do this? First we will put this into a stack. So what we will get? A, then plus, then we will get the value B. So first of all you need to pop the B section and then pop the plus section. After putting the plus section into another stack, this will go like this one, and then put A and then B. That will create the prefix section. But if you want to create the postfix section, first of all you need to put the A then B then the plus section. That will be the postfix notation. In this section we have discussed about these points that we have already seen. Backtracking we have already discussed. It means your way through a maze and find the path from one point to a graph. In this memory management section, we can see here that we have object heaps, then unused memory, then call stack, and static vars, and etc. elements are given here. You can have a snap of this diagram if you want to study further. Here are some advantages and disadvantages of stack. Stack is easy to start and low hardware requirement. It is also cross-platform. And disadvantage, are given here. That's for today. Thank you.